Hello, my name is Nishant Balapur, and I'm presenting my work done at UIUC titled Text Fact Transfer. So to give some motivation for our task, there is this task of text style transfer, which aims to alter style without modifying content, where style can encompass things like sentiment or writing complexity. But there is this complementary task that has not been explored, where you can try to alter content without modifying style. So, for example, you can try to transfer between source topics of different colleges to generate new factual content for a different college. So given this, we propose the task of text fact transfer, where as inputs we are given a source text, a source topic, a target topic, and a knowledge source containing facts about the target topic. Our goal is to generate, of course, a target text that is relevant to the target topic. Two properties of this output is that, one, it should be factually correct, containing information about the target topic that are grounded in the knowledge source, and it should match the style of the source text. And in this work, we define style as the phrasing and specificity of the text. Some potential benefits of this task that we don't explore in this work, but could be interesting for future work, is that you could use text fact transfer for dataset augmentation. If you have a smaller dataset, you could try to expand it by generating new factual training examples in a similar style. And some real-world applications could include adapting news stories and repurposing educational materials, which are both forms of text fact transfer. So we find that text fact transfer can't just be completed with existing models due to some unique challenges. First, a text fact transfer model should not hallucinate factual errors. Secondly, a text fact transfer model should preserve the wording in the source text, but this does not always happen, interestingly. So, for example, in the lower right, when we try using GPT 3.5 for text fact transfer, it changes the wording of belongs to, found in the source text, to was a member of the African National Congress, which does not effectively match the style of the source text. Third, each target text should maintain the specificity present in the source text. So this sequence-to-sequence model in the lower left says that Nelson Mandela belongs to Rhodesia, and while he might have some links to Rhodesia, it actually doesn't match the specificity of the source text, as the source text describes a political party of Joseph Stalin, so the target text should also show a political party. And these challenges become even more difficult in zero-shot text fact transfer settings. And if we want to create an adaptable text fact transfer model, we want to explore the zero-shot setting, which is why we also explore it in this work. So given these limitations, we set out to design a text fact transfer model. To do so, we follow the idea of Lee et al., who show that text style transfer can be performed by extracting words related to the source style and replacing them with words related to the target style. So to do this, there are two questions we need to consider. First, how do we extract the entities that need to be transferred? We find that question generation is one solution, as factual entities are inherently question-driven. So for example, if you have this sentence saying that UIUC was founded in 1867, if you run an end-to-end question generation model, you can jointly generate the question, when was UIUC founded, with its associated answer of 1867, and this can indicate to us that 1867 is an entity that should be transferred. The second question we need to consider is how do we transfer these entities to the new topic? We find that transferring the entity itself is difficult, but transferring the question can actually be quite trivial. So if you have a question like when was UIUC founded, and you want to transfer it to a new topic like UMD, you can simply replace UIUC with UMD to get the question when was UMD founded. And using this question, you can run some type of QA model to obtain the answer and thus the transferred entity for 1867. Given these ideas, we design a model named ModQGA that aims to exploit these findings. So our model uses as inputs the target topic, and source text, and we first run an end-to-end question generation model to jointly generate questions and their associated factual entities, and these entities correspond to the entities that must be transferred from the source text. Next, we run a question transfer model, which essentially just replaces the source topic with the target topic. So if you have a question like what is the size of UIUC, you can transfer it to what is the size of Stanford. In our third step, we run a specificity-aware question answering model, which uses the transferred questions in factual corpus as inputs to obtain transferred entities that both answer the transferred questions correctly and match the specificity of the factual entities. And we note that these question generation and question answering models are trained on squad datasets. So up until this point, ModQGA is still a zero shot. This is changed for our model in the last step where we need to infill the source text with these transferred entities. So a zero shot model could simply replace the factual entities with their transferred entities, but to make this a supervised model, we can use a sequence-to-sequence model to do this instead. We evaluate ModQGA using zero-shot and supervised baselines. So in the zero-shot setting, we find that ModQGA outperforms baselines in both traditional metrics like Rouge, as well as some factuality metrics like FactCC. The datasets we test on, these first two are expository text generation datasets, another paper of which I'm presenting here at EMNLP, which you should definitely check out. And the last two datasets are relationship triple datasets. We find that zero-shot ModQGA outperforms baselines on almost all metrics. The supervised setting tells almost the same story. One interesting thing I wanted to point out is this qualitative analysis of the ability of our QA model to control specificity. To do this, we pick out a question, like what is the setting of University of Florida, and we change the transferred entity, which in theory should change the specificity of our answer. We find that when you do change the specificity of the entity, our model does have the ability to change the specificity of its answer. So for example, when you provide urban as the specificity guidance, it returns residential, while the nation's capital also returns the state capital. And yeah, that's everything I wanted to present. Thank you so much for listening. If you're interested in learning more, please check out our paper or code. Thank you.